take some time on, and then the last four obviously go pretty quick. But this is homework from Friday, guys. This is all of page 4 on day 1. Would somebody care to maybe just give us, you can just give us like a 1-sentence explanation kind of on how we would find angle A on number 1? Go ahead, Angel.
You have to find x and then plug in.
Yeah, so you find out what x is, and then you plug that back in, plus 76 to find A. Now, how did you find out what x was?
Added the x plus 57 plus x plus 87 plus 4.
Mm-hmm. And what does that all add up to be?
Negative 7.
Well, I'm saying, what does that all add up to be equal to?
180.
180. We know there's 180 degrees in this triangle, so that plus that plus that should all add up to be 180. Yes, ma'am. And like you said, that gives you an equation you can solve for x. Check it out. You end up combining like terms, guys. X plus x is 2x. 67 plus 87 plus 40 is 194. Subtract that 194 over and divide by 2. And like Angel said, you can't stop with finding x. You got to plug that in, find out what it is. And you actually do the same exact thing on number 2. So if you want to kind of see number 2, there you go. See if you guys have any, scoot this over. Anybody maybe have some questions as far as how we solve these? Maybe a step in here kind of confusing you? This chapter is going to be all about triangles. So if you kind of have some basic fundamental issues with triangles, please let me know because we want to get those sorted out. How about, David, what kind of triangle is number 3, man? An obtuse? Say that one more time. Isosceles. Well, I'm actually really curious. What did you say the first time? You almost didn't get it. That was nice, man. Good job. Yeah, you're absolutely right. I like that. I'm going to have to start calling it's like parabola. Whenever a kid says parabola instead of parabola, I always want to just call it that from now on. How about, well, I just gave it away. Not even going to pretend on that one. Number 4 is acute scalene. And real quick, Jake, what makes something a scalene triangle? Sure, the different angles. And what do the different angles give us? What do they tell us about the sides? Say it again. It does tell you how big they are, but also it tells you what the sides equal. Do any of these sides equal each other, Jake, on number 4? No, so it's scalene because none of the sides, none of the angles are equal to each other. Yep. And then how about last couple? How about 5 and 6? Let's go, Taya. What kind of triangle do we have on number 5? Equilateral. Straight up equilateral. Not a right equilateral, not an obtuse equilateral. Just an equilateral. How about, Justin, what do you got for number 6, man?
Number 6?
Yep. Hey, you're right. It is obtuse. I see an angle bigger than 90. Cade, help him out. It's obtuse. You do know. Check it out. Fantastic. How many sides do you see are equal, Cade? 2 sides are equal. Do you know what kind of triangle has at least 2 sides that are the same? David, say it again. Iskosky. That's right. No, I was kind of hoping you just stick with the first one. An obtuse isosceles triangle. Yep. 2 sides are equal, so it's isos. That's what I sometimes call it, isos. It's a really lame math reference. And then it's obtuse because it's bigger than 90 degrees. Let's go. Any questions, guys, on the heart and soul? The heart and soul of this day is all on the first page. Everything that we're going to talk about today is all going to come from the top half of this page. So I'm going to give you guys a second. Look at how simple our standard is today. This is like the shortest amount of words we've ever seen in a standard in this class on any given day. We are just understanding angle relationships. We're understanding how angles affect each other, how they add up with each other. And big thing right here, Kenzie, would you care to read us? This is maybe an angle you never heard of. What is an exterior angle?
The angle formed by one side of an extension of the other side.
So that's a little confusing. Look at the picture we have over here on the right, guys. An exterior angle comes from whenever you have one side of a triangle that just keeps going. And we see that, okay, here's one edge of a triangle, here's the angle that keeps going, and there's now an angle on the outside of the actual triangle. This is on the outside of that triangle. So that's all an exterior angle is. Now here's the key with it. You may be thinking, well, how do we find out what it is? Ethan, what kind of angles do we have inside that relate to that? What's our second definition here, man? This is going to be the big one. This one and our next one. What are remote interior angles, Ethan?
They are the interior angles that are not adjacent to the exterior angles.
Whoa, what was that word? They are not. It's not that they're adjacent. They are not adjacent. And what is that word, Hunter? When I say adjacent, what's that word mean? Come on, where's my English people? Go ahead, Isabel. It means beside. So guys, your remote interior angles are not beside. English was always my best subject, so that's words were always something I was actually kind of decent with. So it's not beside the exterior angle. So look at our picture up top, guys. Actually, you can look at both these pictures. Check it out. Remote interior angles are always the two angles that are not beside the exterior angle. They're on the opposite side of the triangle from it. You're going to notice that there's always an angle that's beside the exterior angle. A remote interior, when you think of the word remote, I think of like Antarctica, right? Somewhere remote where there's not a lot of people, not a lot of things happening. My house, very remote, very boring, nothing happening. But that's what remote interior angles are. Now, Lily, here's the key. How do we find the measure of the exterior angle? So if we have an exterior angle, how do we find its measure?
The sum of the two remote interior.
Right there, guys. You take interior angle 1, add it with interior angle 2, and you're going to get the exterior angle. Did you catch that, Cody? How do we find the exterior angle? You got to do whatever I wrote up here.
Add both sides.
Sides.
Yeah.
What? We're talking about angles, man. We're going to add both these interior angles together. And when you add those two together, they give you what the exterior is. So now's a good time to ask. 1 plus 2 is going to give you the exterior angle. No problem. And then I'm not even gonna waste time with the third angle theorem. Jack, what's it looking like on that third angle theorem? All that's saying is
If two angles of one triangle are congruent with two angles of the same triangle, then the third angles of the triangle are congruent.
that makes sense, right? If two angles are the same, then obviously the third has to be the same because they all three are going to add up to be 180. We're not going to waste any time on that one. And then finally, guys, last thing before we start to actually get some work in. This one's a little bit tricky when you first look at it, but it actually makes a lot of sense. This has to do with if we have a right triangle. So I'm going to give you guys, let's take about 20 seconds. I just want to give you a chance to read over this because once you read over it, it actually is a lot easier. All right. David, what's a good summary, man, of this corollary? What's just kind of one thing you pulled from it? Sure. So what we're saying is if you have a right angle, David, does it make sense that if you have a right angle in a triangle, that's 90 degrees? How many degrees are in total in a triangle? 180, yeah. So would it make sense then that A plus B will have to be 90? If that's 90, won't these two have to be 90 as well? Because 90 plus 90 gives you 180. That's all that's saying, man. That's all that's saying. Say it again, Jacob.
Don't you
They actually don't have to. Check it out. David, or Jacob, we could have this angle be 50 degrees. This angle could be 40 degrees. But here's the thing. If there is a right angle in there, what kind of angles do these have to be? Acute. Because this is 90 degrees, guys. You can't have an angle bigger than 90 between these two because you already have 90. You already have half of the triangle's degrees right there. Yep. Well, yeah, you just have to have enough pieces, man. We're actually going to talk about that down here. What I'm going to let you guys do, I'm going to let you guys see if you can try, based off the definitions we've got up top, I want you to see if you can try 1 and 2 here. Treat it like dominoes, not the pizza. It's like dominoes as in, look for a piece, and once you find that piece, you're going to see every angle starts to come together. You're going to be like, okay, I found that angle, now I can find this angle, this angle, this angle, this angle. Go ahead and try 1 and 2 for me, guys. Find every angle. That means find CBD, this angle, and find ECF, this angle. So you're finding this angle, this angle. You're finding 3 exterior and 1 interior angle is what you're finding here. I'm going to go ahead and call this remote interior angle ABC. Remember, the middle letter is always where the angle is. So we'll call that ABC. And I'm going to call this EAB. And you can keep on working. I'm just going ahead and labeling these. That way, whenever I call on you guys, you can be ready to help me out. ACF. And DBC. All right. Let's see what you guys got here. How about Dakota? Would you care maybe to help me out on the interior angle? What was our third missing angle inside ABC? Okay, that's okay. We'll see if somebody else can maybe help us out. And you can double check this here. Anybody want to help her out? What? ABC. This angle right here. Let's go ahead, Lily.
118.
How'd you get 118?
I added up 39 and 23 and subtracted it.
Yeah, guys, if we know 2 angles to a triangle, think back to Friday. If you know 2 angles to a triangle, it's super easy to find the third. Add them up and subtract them from 180. So subtract that from 180, and you said, was it 118, Lily? Thank you very much. How about our 3 exterior angles? This is where it gets a little interesting. Let's start with EAB. That's this one right here. Can anybody help me maybe find this one? We got an exterior angle. Think back to what, who was it that read this out? Was it Ethan? Or no, it was somebody else. No, I was picking on Cody with this. We said that to find an exterior angle, what do you add up, Cody? Yeah, so in other words, if your exterior angle's here, you add up to 2 angles that are far away from it. They're going to add up to be it. So can anybody help me out with EAB? How about the virtual children? Let's go. Who am I not called on? Don't know a lot of people, but. Jacob, go ahead, man. Is it 157?
I think.
For EAB? How'd you get that, Jacob?
I added 118 to 39.
Now you're
subtracted, sorry.
No, you're good. No,
added.
you would add. Now here's the thing. You're so close. We do use 118 because that's not beside A. But it's 39 beside A.
Oh, yeah.
So we can't use that angle. Remote interior angles are the 2 angles that are not beside it. So you would do 118 plus not 39, but yeah, 23. So you were on the right track, man. So I'll let you fix that real quick. You can tell us what you got here in a second. 141, yes, sir. Good quick math. How about ACF? I feel like that stands for something. Anybody? Go ahead, Jack. That would be this angle right here. Yep, that would actually be the one Jacob did. 118 and 39 would give us Good quick math, Jack. Jack.
157.
Hold on,
You're good. Yeah, I'll give you some time.
157.
There you go.
Come on, Jack.
How about last one? Let's go DBC. This is going to be this angle right here. So we got 157. We got 141. All these are obtuse angles. Last one. CBD or DBC. Come on now. You've already had two people do these for you, so I know we can do this last one. 72? How'd you get that? You take 39 degrees, this angle over here, and add it to 23. Those are the two remote. Nice work, guys. So 62 degrees. I think it's 62.
Yeah, 62.
Yeah, I was gonna say,
62.
Did somebody say 72? That's okay. So guys, we're gonna actually stop here, and your homework that I really, sounds like some of us really could maybe use a little bit of practice on, is gonna be on the back page. So our homework, I'm gonna let you guys try. This first one's awesome. I love this problem right here. I'm gonna see how much you guys can do, and if you can't do all this, that's okay. I'd really like to test you guys on this first one. Number 1 and number 2 on page 2.
Are you gonna give us the things that we have to find?
Well, I already have them. They're numbered. You're going to find angle 1, angle 2, angle 3, angle 4, angle 5, and angle 6. Yep. And remember what I said about this being like dominoes? You have to find one piece, and once you find one piece, the other pieces start to fall. So guys, we're going to be doing numbers 1, this big crazy looking piece, and then number 2. And make sure you read carefully. And so that'll be our homework for now.